Today, we're not going to worry about importing a data set that somebody else created, but we're going to create our own data set by using simulation. So to do that, we want to collect data by using a list. So a list is a construct in Python where we can collect multiple variables inside of a single variable.
Interesting. So it's different from a data frame.
It's different from a data frame. It's a more primitive type. And it's going to be used for us to collect a bunch of simulation results before we bring it to a data frame. So I love the classic problem of rolling 2 die at the same time. So I want to roll a blue die and a red die. And I think this is a hard problem because a lot of people struggle thinking about the idea of what happens when you roll a red die and it gets a 4 and a blue die getting a 2. What's the probability of this happening? It's hard to kind of think about probabilities as things get complicated. So what we're going to do is we're going to collect a number of different simulation results of rolling 2 die. And this is a rather simple simulation, and we're going to need to do a loop because I don't want to just roll these dice once. I want to roll these dice 10,000 times.
Oh my gosh.
So what we're going to do is we're going to start collecting data in a variable called data. And we're going to say data is equal to square brackets. And this is a list. So we are going to create an empty list. And we're going to use this list to collect all of our simulation results. And then we want to simulate, I think I said 10,000 times.
You said 10,000. So we're going to store all of those 10,000 dice rolls in data?
In the single variable data.
Got it.
So to do 10,000 dice rolls, we need a loop that's going to run 10,000 times. So to do that, we have for I in range 10,000.
Ooh, wait, I have a question.
Yes.
As I'm typing this into Python, do I put the comma in 10,000? It looks like you didn't.
So yeah, a comma is an extra character and Python doesn't understand commas.
Perfect.
So we need to write just 10,000, so 1 followed with 4 zeros. And then the third thing I need to do is I need to think about the real world events that are happening when I roll a die. So I see 2 individual real world events here. I roll the red die and I roll the blue die. And these happen at the same time, but in Python we can only do one thing at once. So I'm going to go ahead and say create a variable called red, and that's going to be the result of rolling a red die. And this red die has 6 sides, so random.rand int 1,6 is simulating rolling this red die and getting one of the 6 possible outcomes randomly. I'm going to do the exact same thing with blue. Blue is equal to random.rand int 1,6, and this rolls the blue die. So what we have is we've rolled 2 die, and now we need to collect this data in the variable data.
Yes.
So to do that, I'm going to stick this data in a dictionary, which
What's
is
a dictionary?
It's our final construct that we need. And it's a notation in Python, and I'm just going to call this dictionary D for dictionary. And I'm going to use curly braces. And a dictionary is a collection of key value pairs. And the key's name is going to be the name of our variable. And we're always going to follow this syntax. So this dictionary is going to be a curly brace. Then inside of quotes, we're going to say the dictionary entry for red is going to be, and we're going to say colon is assigning the value in a dictionary. So red is going to be assigned to the variable red. And then comma, because we need to separate all of dictionary entries with comma, blue is going to be assigned the variable blue. And then we'll close the curly brace. So this collects the red roll and the blue roll into a single entry. And then the final thing we need to do is we need to say data.append. And then inside data.append, we're going to use parentheses and put this variable d. And that's going to add a collection of all of our data, all of our real-world simulation results, into our big list data. And this is going to run a total of 10,000 times. And now we want to do the final, so all 4 of these lines are indented, because all 4 of these lines need to run 10,000 times. Now, the very last thing we need to do is we need to now take all of this data and put it into a data frame.
Yes.
Because what we want to do is we want to do analysis of this. The simulation itself is interesting, but what's really interesting is what we get when we finish the simulation.
Exactly.
So to do this, we're going to create a classic data frame. So we're always going to be calling our data frames df by default. So df is equal to pd dot sorry, we're not reading a CSV. We're going to say df is equal to pd dot data frame, capital D and capital F in data frame. And then our data that's going to be in our data frame is data. So this is very similar to pd.readCSV, which we use when we want to use somebody else's data. But here we have our own data, so we're going to create a new data frame with the data in data.
And it looks like we're using the pandas library. We have PD right there, and the random library. So I need to make sure that when I'm typing this on the computer, I import pandas as PD and import random.
Exactly. So here in this program, we're having to use 2 different Python libraries that's going to do some of this functionality for us. So yes, import random to import the random library, and import pandas as PD. So if we run all of this code, we're expected to see that we're going to take a little bit of time because we're doing something 10,000 times. And we're expecting to see that we're going to create a data frame that has all of this data in it.
And it's important to note too that this piece of code is not indented because it's not part of our for loop.
Exactly.
So I'm going to go ahead and run this.
And what I expect to see is I expect Carly to see nothing at all if this works. So no result is a good result.
So it's still going. It just ended, no result.
Awesome. And what that means is it ran without any errors, but we didn't ask Python to actually print anything out. So what I always like to do is I write the simulation in one block of code so I can always rerun this block when I want to resimulate results. And then in a second cell, let's actually just see what's in the data frame. So let's type df, and we should see the contents of this data frame.
It has 10,000 rows, 2 columns. The columns are labeled red and blue.
Awesome. And what's a couple of rows of data of red and blue?
Let's see. So the first one I got 5, 5, 4, 4, strange, 2, 4, 4, 3, and 5, 6.
So what we have is we have basic simulations of these dice rolls. So we have 10,000 rolls of these dice, completely randomly between red and blue. And you'll see that this red variable came from the fact that we collected the red data in red. The blue variable came from the blue variable here. So in summary, I want to just wrap up this whole thing and think about this as a simple recipe. That there's always going to be 6 steps that we're going to follow for every single simulation we're always going to do, no matter how simple or how complex the simulation gets. The first step's always going to be creating an empty list that's going to store our data. The second step is always going to be creating a for loop that's going to loop around as many times as we want to do the simulation.
Mm-hmm.
The third step is always going to be simulating all of the real world variables. So if I was rolling 3 dice, this would be 3 lines of code. If I was rolling just 1 die, it'd be 1 line of code. If I was simulating the launch of a rocket ship, these real world variables may be 10,000 lines of code to simulate all the variables of a rocket ship. So this is going to grow and shrink as we have more and more complicated or simple simulations. The fourth step is always going to be to accumulate all of the real world variables inside a dictionary D. The fifth step is always going to be append this dictionary to our data list. And then finally, the last step, which is outside of the for loop, is going to be convert this data to a data frame. And then once we have this data frame, we have all of the tools of a data frame to do analysis on this data.
Yes, that's where we can analyze the data and do different statistical techniques to see what we actually got.
So we did a really simple simulation here of rolling some dice, but we're going to get complicated quick because it's so easy to write simulations if we can just identify the real world events that we need to simulate.